In this screencast, we're going to talk about what's called the sampling distribution of one population proportion. So often we're interested in studying the percentage, the same as the fraction, the proportion, which is the language we use, the proportion of a population with a characteristic or in a certain category. So a candidate for office might want to know what proportion of voters are planning to vote for her. That's what polling is all about. Or a CEO wants to know what proportion of customers are satisfied with customer experience for marketing purposes or quality improvement purposes. Or a medical researcher wants to know what proportion of cancer patients are taking a new drug. What proportion of cancer patients who are taking a new drug will be cured. So that's the kind of thing we're interested in, where we want to know about one population proportion. So here's an extended example just to help us get specific. So we're given that about 18% of adults in the US smoke cigarettes. If we survey just a sample of adults, what proportion will we find? Does it have to be 18% of every sample? Well, of course not. We could get a sample in which only 5% smoke, or 21%, or 32%, or 19%. Anything could happen. And what the sampling distribution is going to tell us is what does happen and how likely. So of course anything could happen, but they're not all equally likely. So just some notation, some ways that we talk about things and write things in statistics. When we're studying a population proportion through samples, we use the letter P to stand for whatever proportion we're interested in for the whole population. N is the number of individuals in our sample, whatever sample we're choosing, and P with that little symbol on top is called P hat. And that stands for the sample proportion, the proportion of our sample with the characteristic. So suppose we survey 800 adults and we found that 162 of them smoke. Then P is 0.18. That was given that 18% of all US adults smoke. N is 800. That's the number of individuals in our sample. And P hat is 162 out of 800, which is about 0.20. That's the sample proportion, or rather the proportion of our sample who smoke. So of our 800, about 0.20 of them, or 20%, smoke. And the whole point of the game is that most of the time we don't know P, and we're going to use P hat to learn about P later, not today, not in this screencast. Now back to our previous point. If we take samples from our population, we could find P hat to be anything. In this last example, even though P was 0.18, we found a P hat of 0.20. But it turns out that those P hats follow a normal distribution with mean P and standard deviation square root of P times 1 minus P over N. And that's kind of amazing. If a population proportion of interest is P, then if you look at the collection of all sample proportions P hat for a particular sample size, this is called the sampling distribution of the proportion, the collection of all possible P hat for a particular sample size. This follows a normal distribution. It has mean P and standard deviation square root of P 1 minus P over N. And now we can use everything we know about normal distributions to answer questions about proportions. So given that 18% of adults smoke, then in a sample of 200 adults we could find any sample proportion, but they're not all equally likely. They follow normal distribution with mean P, 0.18, standard deviation, square root of 0.18, 1 minus 0.18 over 200, or 0.027. So if we knew that the population proportion was 0.18, then we could say what would happen, or what could happen, when we take a sample of 200 adults. Sure, any proportion could come up, but they're going to follow a normal distribution. So let's see how we use this theory to answer questions. If we do sample 200 adults, what's the probability that in our sample we get less than 0.15 of them who smoke, or less than 15%? Remember, for the population as a whole, it's 18%. But it could happen that we get less than 15%. So Z, right, we're talking about a normal distribution now. Z is 0.15 minus 0.18 over 0.027, which is negative 0.11. 0.027, where did that come from? Back here, remember? .027 is the standard deviation of the sample proportions. So we get a z of negative 0.11. We put that into norm S dist and get 0.13. And that tells us that there's only a 0.13 probability of getting a sample proportion less than 0.15. If the proportion of all US adults who smoke is 0.18, then there's a 13% chance that in a sample of 200 adults, you'll find that the proportion of that sample who smoke is below 0.15. And don't let all these proportions and decimals confuse you. Make sure you know what they mean. 0.18, that's the proportion of the whole population who smokes. 0.15 is the proportion of the sample, the particular proportion we're interested in. And the 0.13 is the probability that that sample proportion we would get is less than 0.15. So if we were to sample 200 adults, there would be a 13% chance that 0.15 of them or less are smokers. Let's look at one more example. If you sample 1,000 adults, what's the probability that more than 200 of them smoke? Well, p is 0.18 still, but now, and p hat equals 200 over 1,000, that's the number we're interested in, 0.20. And now the standard deviation is 0.012. So our z is 1.67. Norm S dist at 1.67 is about 0.95, but remember we want more than this time, so we have to subtract from 1. 1 minus 0.95 is 0.05, so there's only a 5% chance we would find 200 or more smokers in a sample of size 1,000.